Hi everyone. So in this video, we're going to come back to what we started, which is describing a distribution. So we've covered our options for the center, and we were kind of in the middle of talking about our options for the spread, which were so far the range and the standard deviation. And we decided that the range wasn't good really for any description because it's so non-resistant to outliers and skew. And then we talked about the standard deviation, and because the standard deviation, the formula for the standard deviation uses the mean, that value is best used when describing the spread of a distribution that is unimodal and symmetric, and that led us into the empirical rule and z-scores. But we now want to come back to the other option for describing the spread of a distribution, which is the IQR. So the question is, what measurement do we use when a distribution is skewed or has outliers? So before we get to that, I just want to do a little bit of vocabulary, which is the percentiles and quartiles. And a little warning, your textbook does a whole bunch of by hand calculations for percentiles, and we will never do that in this class, so you can skip right over it. But I do want to talk about what a percentile is. So a percentile, an nth percentile, means that it's that data value, it's n% of data values are below that given data value. So for example, you see this a lot when children are born. They'll say like their head circumference is in the 65th percentile, meaning their head circumference is 65 or is greater than 65% of other measurements of babies the same age. So the median is therefore at or near the 50th percentile, because remember we said the median, half the values are below and half the values are above, so the median is at the 50th percentile. The reason we have this little at or near piece is because it does depend on whether or not you have an even or an odd number of data values. We also want to specifically look at the 25th percentile and the 75th percentile. And the 25th percentile we call the first quartile. So think quarters, 25 cents in a dollar. First quartile is the 25th percentile. And the third quartile, 3/4, is the 75th percentile. We need these values because this is how we calculate the interquartile range, or the IQR. And the IQR, it turns out, is the best measure for the spread of a distribution when that distribution is skewed or has outliers. So the interquartile range is kind of like a regular range, except for we're only talking about the middle 50% of the data. So remember that Q1 is the 25th percentile, meaning that 25% of the data values are below Q1. So here's Q1 right here. And then we have Q3. So that means that 75% of the data values are below that. Or the other way you could say it is that 25% of the data values are above it. Meaning that this distance, Q1 to Q3, gives us the middle 50% of the data. So this is the range of the middle 50% of the data. And this value is going to be resistant to skew or outliers because the skew or the outliers are never going to be in the middle of the distribution, right? So you can see here that this skew, it's way out here. It's not part of this blue measurement here. So to kind of put this all together, and I know this slide is just a whole bunch of words, but these are kind of the notes that I think you should take away from this. So if we put all this together, we use histograms, dot plots, and stem and leaf diagrams to display the distribution of quantitative data. When we then want to describe that distribution in terms of its shape, center, and spread. And when we describe the distribution's shape, We talk about whether or not that distribution is skewed or symmetric. We talk about the number of modes, meaning it's unimodal, bimodal, uniform, or so on. And we talk about any unusual features, specifically the outliers. And again, we will talk more about this very, very soon. So that all encompasses discussing the shape, but then we also want to describe the center and the spread, meaning we want to choose the best measure that for that distribution. So if the distribution is skewed or has outliers, we would choose the mean and the IQR. That's incorrect. If the distribution is skewed or has outliers, we would use the median and the IQR because both of those measurements are resistant to skewness and outliers. We would say that the median is the best measure for the center and the IQR is the best measure for the spread. Or another way to say that is that the median best describes the center and the IQR best describes the spread. If the distribution is approximately symmetric and unimodal, then we would say that the mean best describes the center and the standard deviation best describes the spread. And again, that's mainly because those values can then be used to also discuss the empirical rule and z-scores, two other things that are important when discussing a distribution that's symmetric and unimodal. So let's look at a couple of examples of this. So we have here a histogram to the right shows the percent change in the prison population in 21 states between the years 2010 and 2015. So the first thing that we want to do is describe the histogram's shape. So we're going to describe whether it's skewed or symmetric, the modes, and whether or not there's any unusual features. You don't have to give me any kind of big paragraph here. We've got, it looks like one major mode with a skew. So we would say that this is skewed left. It's unimodal. And it looks like there's one possible outlier here, but we really don't know for sure because we don't get into the calculations for outliers until we talk about box plots. Just because there's a gap in a histogram does not necessarily mean that this is for sure an outlier. So I'm going to be sure to use the wording that there's possibly one outlier. But I don't know for sure yet. Based on this shape, would I expect the mean or the median to be higher? So remember that the mean is not resistant to the skew, which means that the skew is pulling the mean in that direction. So if they had both started off in the middle, the mean is being pulled to the left, meaning it's being pulled to the lower values. And so in this case, the median would be higher. What would be the most appropriate measure for the center and spread of this distribution? Well, since this distribution is skewed, the best measure for the center would be the median. And the best measure for the spread, that's an A, is the IQR, or the Interquartile Range. And then I have a couple of questions here asking about interpreting this histogram. It says, how many states saw a decrease in their prison population? A decrease meaning that the percent change is going to be negative. So if I read this frequency histogram here, I've got one state here all the way across. This is 6, 6, 4, and 2. So the number of states that have a negative percent change, if this is 0, I've got 3 states have a negative percent change. So 3 states saw a decrease. And then it says, and notice it's saying how many. So be really careful with the way the question's wording, because look at part E, it says what percent. So now I'm doing a slightly different calculation. What percent of states saw an increase of 5% or higher in their prison population? So here's 5%. Looking at 5% or higher, the number of states that are high 5% or higher is 6, but I want the percent, so I need to divide by the total. And the total's up here, it's 21. So I have 6 states that are 5% or higher out of 21, giving a percentage of 28.6%. All right, let's do one more example here. And this says that students in a biology class kept a record of height in centimeters of plants for a class experiment. And there is the data there. And it says find the following statistics. So this is where you're going to use your calculator and you're going to find all of these values. So I have like a little calculator video here. So you're going to put all the data in L1, which I already did. And I'm going to quit out of that and go to Stat, Calc, and one variable stats. The list, all of this is usually here, and you just have to arrow down to calculate. And I'm going to stop it right here for a second. So remember that X bar is the mean. So I can see right here that the mean is 51. This is a sample. So I'm going to use the sample standard deviation, which is the S of X, and that is going to be 10.64. The median, I need to scroll down, so I'm going to let this video play a little bit longer. Come on. There we go. So the median we have is 50.5. And the IQR, remember, is Q3 minus Q1, the distance between the third quartile and the first quartile. So when I read these off, I'm going to have 57.5 minus 43.5, giving me an IQR of 14. The next part says, look at the histogram of the data using your graphing calculator and describe the distribution. So I'm going to play this a little bit further because it's going to show how to look at the histogram, and it's under Stat Plot right here. So I'm going to quit out of this. Oh, I didn't show it. I just hit Zoom 9. So I apologize. It's probably in an earlier video. So when you're looking at this, make sure you go down to the bottom of this page on Chapter 3 and look at the videos that show how to enter a histogram in your calculator. But here's the histogram, and we're going to then describe the distribution, which means that we need to get through all 3 categories: shape, center, and spread. So for shape, we would say that it's skewed right. Right, we have this skew going on here. It's unimodal, and it doesn't appear to have any outliers, but we really don't know for sure. So no outliers. This is all part of the shape of the distribution. We then want to talk about the description for the center, and since this is skewed right, the center would best be described by the median, which we established was 50.5 centimeters. And then for the spread, the best description, again because this is skewed, is the IQR, which we found is 14 centimeters.